Hello everyone, today we're talking about parallel lines and proportional parts. So these are your 7.4 notes, which you should have the sheet to go through these on. We've got two objectives: use proportional parts within triangles and use proportional parts with parallel lines. So proportional parts within triangles, we'll start with our first objective here. Theorem 7.5, the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So what's going on in this theorem? Okay, BE, this segment, is parallel to one of the sides. It's parallel to the side CD. So those two are parallel. And BE also intersects the other two sides. Okay, and so what it's doing here is, if you can imagine, just kind of extending BE, okay, well, it means that AB, A to B, over the shorter segment there, BC, is proportional to, we can do the same thing on the other side, AE, the longer segment, over the shorter segment, ED. Okay? And so that's, again, if BE is parallel to one of the sides, which it was. Okay? So in triangle PQRS, this is example 1, ST is parallel to RQ. You can see those are marked with the arrows. If PT equals 7.5, TQ is 3, and SR is 2.5. Find PS. So again, just imagine an extension of this, okay? And so that would give us PS, let's call that X. X over 2.5 should be equal to the longer part on the other side, 7.5, over 3. And so again, you can kind of even imagine this line here as being part of your fraction, part of your proportion. X over 2.5 is equal to 7.5 over 3. Now we're just solving a proportion. 3 times x, 3x, and I need my calculator. As always, I'm not the arithmetic guy. What's 7.5 times 2.5? Well, that is 18.75. So we divide by 3, and x is 6.25. Which was the segment? We used x to mark the segment PS. So PS is 6.25. Okay? So that's using the triangle proportionality theorem. Guys, this is the converse of the triangle proportionality theorem. So guys, what this is saying is, if AE, so if the shorter segment over the longer segment over EB is equal to CB over, or excuse me, CD over DB. So if they're proportional, so you got to check that, well then you can say, okay, yes, they are parallel. Okay? And so this is just going the opposite direction of what we had just done. And so example 2 here, determine if lines are parallel. So they give us some measures here. EH is 3, HF is 9, and DG is 1/3 the length of GF. So DG, well, what is GF? Well, GF is unknown, so let's just call it X. And then DG would be 1/3 of that. 1/3 of X. Okay, so are these equal? Are these pieces equal? Is 1/3 X over X equal to 3 over 9? X over X, those can cancel, so we would be left with 1/3 is equal to 3 over 9. That is true. if you reduce this, or you can cross multiply to check. But yeah, if you reduce 3 over 9, that's 1/3. So yes, those are equal. So if this is true, which is what we were checking, if those segments are proportional, which they are, then yes, DE is parallel to GH. Yes, they are. Okay. And so I'm going to keep the same picture here. I'm going to erase on the picture because part 2 is trying to get us to use that same triangle here. So DG is half the length of GF. So DG, it's very similar. So if GF again is X and DG is 1/2 the length of X, EH is 6 and HF is 10. So this would be the proportion we have. 1/2 X over X. Does that equal 6 over 10? Similarly, cancel your x's. So is 1/2 equal to 6 over 10? No, 1/2 does not equal 6 over 10. So DE is not parallel to GH. They're not parallel because the proportion was not, or the proportions weren't equal. Okay, those segments weren't proportional. Okay, a mid-segment of a triangle, so this is our definition here. A mid-segment of a triangle is a segment with endpoints that are midpoints of the sides of the triangle. So an example of I'm going to draw a mid-segment here. So this side has a midpoint. I'm just kind of estimating here. That would make those two parallel. And this other side, this side over here also has a midpoint. Going to kind of guesstimate it as well. Again, what would make those two pieces parallel? So this here, let's call it AB. That is a mid-segment of this triangle. Again, it connects the midpoints of the sides of the triangle. Okay. So the triangle mid-segment theorem, theorem 7.7, states that a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. Okay, so the length of the mid-segment, let me write this out. Let's use this example up here, and then I'll leave you guys the example on the theorem. So if we're using this triangle here, let's call this AB, so let's call it CDE. Okay, so AB is the mid-segment of triangle CDE. Okay, and so what? So AB, it is parallel to one side of the triangle. So what would AB be parallel to? In this case, AB would be parallel to ED. Alright, and AB is equal to 1/2 the length of ED. So the segment AB is 1/2 the length of ED. Alright, so that's what the mid-segment theorem tells us. So if we're looking at this example, okay, JK appears to be the mid-segment. JK is the mid-segment of triangle HFG. So JK is going to be parallel to that one side, FG. And JK is equal to 1/2 of FG. So that's what the mid-segment theorem tells us. Again, that was just in both those examples. Alright, and this is true for all mid-segments. So we might see an example here where a couple mid-segments are drawn. Okay, yeah, in this figure, X, Y, and YZ are mid-segments. So XY and YZ, both of those are, or excuse me, XY and XZ are mid-segments. So both of those are mid-segments here. Okay, find each measure. So find the measure of XZ. All right, so XZ is going to be parallel to RT because it's a mid-segment. And then the mid-segment theorem tells us that XZ is equal to 1/2 of that segment that it's parallel to, RT. Well, RT, it appears, is 13, so XZ is 1/2 of 13, which is 6.5. So XZ is 6.5. Finding the length of ST. So we want to know the length of ST. Okay, well, we don't really have a lot of information about ST, but we do know that this segment XY, I'm going to make it green now, we know that that is a mid-segment, so those are parallel. And we know, this is kind of the reverse of the problem we just did, we know that XY is equal to 1/2 of ST. So if we plug in XY here, 7 equals 1/2 of ST. We can multiply both sides by 2. 2 times 7 is 14, so 14 must be equal to ST. So you can see how that's kind of the opposite of part A there. So ST is 14. And then lastly, we're trying to find the measure of angle RYX. Guys, we know that this is a, so let's find RYX. Okay, so that is here. We know that this segment and this segment are they're parallel, so this XY would be a transversal, making these two angles alternate interiors. So that must be 124 degrees. Alternate interior angles are congruent. Okay. Continuing, proportional parts with parallel lines. If 3 or more parallel lines, like you have here, AE, BF, and CG, intersect two transversals, the transversals are the non-parallels in this example, then they cut off the transversals proportionally, okay? So what that means is that AB, this segment here, over BC, this segment here, should be equal to EF over FG. Okay? That is how this proportional parts of parallel lines works. AB over BC should be equal to EF over FG. Okay? So this is a real estate problem, talking about frontage. It's the measurement of a property's boundary that runs along the side of a particular feature, such as a street, lake, ocean, or river. Find the ocean frontage for lot A. So if you're looking at the diagram here, lot A, of course that's the top lot. We're looking for the ocean frontage, that measure that is along the ocean there. Okay. So again, we've got parallels. We've got that these lots are all parallel. Okay, and so the proportion here is that x over 60 should be equal to these measures over here, 58 and 42. So 58 over 42. So just cross multiply here. Again, I'm going to need to grab my calculator. X times 42 is 42x is equal to 58 times 60. 3480. Divide by 42. And we get that x is, I think it said round to the nearest tenth of a yard. So 82.85, that would be 82.9 yards. That's the approximate ocean frontage of lot A. Okay. Alright, and then congruent parts of parallel lines. If three or more parallel lines cut off congruent segments, okay, so the parallels here, they're cutting off congruent segments on one transversal, then they cut off congruent segments on every transversal. So this transversal EFG, this transversal, it would also cut into two congruent pieces. And if we continued these parallels and had a third transversal over here, it would cut them into two congruent slices. And again, this stems from our last theorem, again, that these all must be proportional. So if AB over BC equals EF over FG, and so on and so forth, okay, they would all be at a ratio of 1, being all congruent. So here we're asked to find X and Y. Again, our parallels this time running vertically. Okay, it cuts this transversal into congruent pieces, so MP is congruent to PQ. Looks like we can use that to find Y. If it cuts the first transversal into congruent pieces, then it cuts this second transversal into congruent pieces as well. So JK would be equal to, or congruent to, KL, and so we can use that to find X, it looks like. So MP equals PQ, 3Y plus 8 is equal to 5Y minus 7. Do some algebra here, subtract 3Y. So 2Y minus 7 equals 8. Add 7. 15 is equal to 2y. So here, y is equal to 15 divided by 2 is 7.5. And for the x's, jk is congruent to kl. So 6x minus 5 is equal to 4x plus 3. Subtract 4x from both sides. 2x minus 5 is equal to 3. Add 5. And we've got 2x is equal to 8. Or x is equal to 4. Okay. Your 7.4 homework. Well, I'll leave you guys 5A. Okay. I'll leave you guys 5A finding just x on this one. Okay. Again, these three parallels cut this transversal into congruent pieces, so it must do the same to the other. So these segments must also be congruent. So you can set them equal and solve for x. And then your homework, guys, 7.4, page 495, 10 to 26 evens. So go ahead and work on that for the remainder of your time.